In this video, we're talking about how to use conjugate method to simplify an imaginary expression. And the imaginary expression that we've been given is this fraction here where we have 2 plus 3i in the numerator and 4 minus 2i in the denominator. Now, the important thing to know here is that I is not just a normal variable. It's what we call the imaginary number. And remember that the imaginary number is I equals the square root of -1. Remember that we can't normally take the square root of a negative number, but it's really convenient in mathematics for us to be able to take the square root of -1 sometimes. And so to get around that, we call I the imaginary number and we use it to represent the square root of -1. By definition, then, we say that I squared is equal to -1. Now, with these two things in mind, we can use conjugate method to simplify this expression. And when we say simplify this expression, primarily what we're trying to do is get the imaginary number out of the denominator. In the same way that you want to rationalize a denominator and get the square root out of a denominator, you also want to get imaginary numbers out of the denominator. You never want to leave a final answer with an imaginary number in the denominator. So we're going to try to remove this I in the denominator here, and the way that we're going to do it is using conjugate method. Now, when we talk about the conjugate of something, we're talking about a binomial. A binomial is two terms separated by an addition or subtraction sign. So, for example, 4 minus 2i is a binomial because we have two terms, 4 and 2i, and they're separated by a subtraction sign. So the conjugate of this binomial is those same two terms. We keep the 4 and we keep the 2i, but we just flip the sign in the middle. So if we have a subtraction sign, we want to change it to an addition sign. If we have an addition sign, we want to change it to a subtraction sign. So if we want to use the conjugate of this 4 minus 2i, the conjugate is going to be 4 plus 2i instead of 4 minus 2i. So what we want to do is we want to multiply both the numerator and the denominator of this fraction by the conjugate of the denominator. So the conjugate of the denominator is 4 plus 2i, which means we multiply both the numerator and the denominator by 4 plus 2i. So now when we're multiplying fractions, remember that we multiply the numerators together to get the new numerator. So we'll go ahead and say 2 plus 3i times 4 plus 2i, and then we multiply the denominators together to get the new denominator. So we'll say 4 minus 2i times 4 plus 2i, like this. And when we do the multiplication here, what we're doing is we're FOILing out these binomial terms. So remember, FOIL means first, outer, inner, last. That's what it stands for. So when we multiply this out, we multiply the first terms together. So 2 and 4, 2 times 4 is 8. Then the outer terms, 2 times 2i gives us 4i. Then the inner terms, 3i and 4 gives us 12i when we multiply them together. And then the last term, so 3i times 2i gives us a 6i squared. Now we'll need to do the same thing in the denominator. We'll FOIL out those binomials when we multiply them together. So 4 times 4 gives us 16. 4 times 2i gives us plus 8i. Negative 2i times 4 gives us a negative 8i. And negative 2i times positive 2i gives us a negative 4i squared. Now, the reason that conjugate method works so well to get the imaginary number out of the denominator is this. You can see that in the denominator now, we have this plus 8i and this minus 8i, which will cancel with one another. They'll net to 0. And that's always going to be the case when you multiply the denominator by its conjugate. You're going to get those two terms in the center, and they're going to cancel with one another. So now we can just combine like terms. What we're left with in the numerator here is 8. And then plus 4i plus 12i is a plus 16i, and then plus 6i squared. In the denominator, we'll be left with 16 minus 4i squared. And at this point, we need to remember that I squared is equal to -1. So we'll be able to make a substitution for I squared of -1. We want to leave these I to the first power terms alone. So when we make a substitution here, we'll say 8 plus 16i, we leave that I alone. But for I squared, wherever we have I squared, we'll substitute a -1. So instead of plus 6i squared, we're going to say plus 6 times -1. And then in the denominator, we'll be left with 16, so 16, and then minus, instead of 4i squared, we'll say 4 times -1. Now you can see we have 6 minus a negative 1. That's going to turn into a minus 6. Here we have 4 times a negative 1. That's going to turn into a minus 4. Because we have a minus negative 4, that's going to turn into a plus 4. So a plus 4. Now when we simplify here, we have 8 minus 6, or 2, so 2 plus 16i. And then in the denominator, we have 16 plus 4, or 20. So we have our fraction simplified. We just need to reduce it to its lowest terms because all 3 terms in the fraction, the 2, the 16i, and the 20, they're all even. They're all divisible by 2. So we need to divide through each term by 2. So 2 divided by 2 gives us 1. 16i divided by 2 gives us 8i, so plus 8i. And then in the denominator, 20 divided by 2 gives us 10. This then, 1 plus 8i all divided by 10, is the simplified version of the fraction that we started with originally. And we've simplified it because we've managed to remove the imaginary numbers from the denominator. This expression, though, keep in mind that this expression is exactly the same as the original expression. We haven't changed its value at all. We've just simplified it in the same way that we would say the fraction 2/4 is exactly the same as the fraction 1/2. We've just reduced it. We've just written it in a different form, but they're equivalent. They're equal. And the reason is because that when we multiply by the conjugate here, this value, when we multiply by the conjugate divided by the conjugate, of course, these values in the numerator and denominator are the same, so this whole fraction right here reduces to a value of 1. So multiplying by the conjugate over the conjugate is the same thing as multiplying by 1, which of course never changes the value of whatever you multiply 1 by. So when we go through this process, we don't change the value of the original fraction at all. Conjugate method is just a simple way to simplify your original fraction.